Imagine it's 1995. A lamp hops across the screen, a cowboy and a spaceman become best friends, and Pixar's Toy Story changes animation forever. But the innovation didn't stop at the movies. The same creative spark led to the development of USD, Universal Scene Description, a technology designed to wrangle complex animation pipelines. Fast forward to today, and USD is now the backbone of NVIDIA's Omniverse, a collection of libraries and microservices for developing physical AI, such as industrial digital twins and robotic simulation. Hi, I'm Stephen Humphrey, host of Wired In, a show all about the fast-moving world of electronics and high tech. On today's episode, we're talking about Omniverse libraries, the bold concept being developed by one of the hottest companies in tech, NVIDIA. Omniverse libraries enable software makers to integrate pre-built functionality into their solution, including open data interoperability, also known as OpenUSD, real-time world-scale rendering, like the RTX technology, and advanced simulation with physics and runtime behavior. I had the opportunity to sit down with Manish Yashvant, NVIDIA's head of strategic alliances for simulation and physical AI, to talk about the exciting possibilities of Omniverse, including how PTC and NVIDIA are working together to realize it. Manish, thanks so much for joining us today. I know we have a lot to cover, so let's go ahead and dive right in.
Thank you.
Today we're talking about NVIDIA Omniverse, right? And a phenomenal technology. NVIDIA is one of our big partners here at PTC. So, let's just dive right into what exactly is NVIDIA Omniverse, right? The libraries, kind of the architecture, and what kind of, technology did they really enable for design and simulation?
Calling it a library is the right way to look at it. It is not a product. It's not an application that we build. Omniverse is a development platform. It's basically a set of SDKs and libraries for other developers like yourselves to build applications on top of. And the kinds of applications that we envision is, simulation, type of applications. Again, they could be for product level simulations. It could be for spaces like factories.
Sure.
It could be at a city level, and as well as a world level. So we have different scales of these simulated environments, and there are various use cases for these simulations. That's really what we're trying to enable with Omniverse.
Great. No, I appreciate that. And I'm familiar with some of your technologies like CUDA, and I think you guys do a great job with enabling developers with the ecosystem to really unlock the power of things like your GPUs and whatnot. So Omniverse just seems to be more of that you guys are so well known for doing, right?
Exactly. Yeah. I mean, just because we're building accelerated compute or GPUs doesn't mean there's going to be an end application for it. So we have to build a software layer. That's what made us successful. And again, just like we did with a bunch of these libraries for various applications, whether it's for gaming or media and entertainment or for healthcare, this is no different. Omniverse is that sort of software library for simulated environments, again, across various industrial use cases.
Right. So let's talk about some of those real-world use cases, right? So how are companies today using Omniverse and the libraries to create and manage things like digital twins or virtual twins, right? We talk about things like the AI factory. Can you give us some real-world examples?
Yeah, there's multiple use cases for creating a digital twin.
Sure.
One is sort of a design digital twin. So these are for product companies that are building products, whether it's planes, trains, and automobiles. So they want to be able to build a better product. They want to be able to collaborate across multiple disciplines. The hardware design coming together with the electronic and the PCB design, maybe the simulation data, all coming together in one view. In many cases, in automotive, it's not uncommon to have multiple CAD systems coming together in a single design. Like you have the drivetrain created in one CAD system, the shell in another. Maybe you're working with a long supply chain, and you can't really dictate everybody in the supply chain to use the same set of tools, engineering tools. So, but you at the end of the day, you want to visualize all of that in one common environment. So that is one use case for creating a digital twin for the design world.
Sure.
Then there is the simulation world, where you can now create a simulated environment, how that product is placed in its actual working space, whether it's in a factory. Think of a factory like a traditional factory, or it could be a data center, which is what we think of them as more of an AI factory. Data centers are essentially turning into intelligence factories. It's producing intelligence rather than physical products. It could be a hospital where a medical device is being used in an operation, surgery type of environment. So those are, simulated environments. Again, you want to simulate it. You want to do layout planning. You want to do what-if analysis before you put, your investment in building out that factory. So that's the second type of digital twin. The third is an operational twin. So now you actually have built that facility, and now you want to continuously, improve the, performance of that space, whether it's a site, like a factory or a mining environment. So those are three different examples of how you can use a simulated environment.
Yeah, I mean, those are great use cases. And, from my time in the semiconductor industry, I think of something like modeling an entire fabrication facility, right? Like
Yes.
like a TSMC fab, and really getting like down granular to flow of material through the facility and what machines are doing what and how to optimize the layout. And the possibilities are really endless when you think about the applicability of the tools. So when you think about NVIDIA, you also can't really not think about AI. So I'd love to know more about kind of the role AI plays in the Omniverse, and how does that enable smarter, more intelligent product development?
Yeah, so the way we look at AI, if you step back, there's really three waves of AI that's been taking over the world right now. So the first wave was really the generative AI solution that came out 2.5 years ago with ChatGPT. So this was being able to create new or generate new text content, or maybe videos and images or multimodal content based on, again, historical data sets that we train on. So that's sort of the first wave. And that's unlocking a lot of productivity for the human workers and knowledge workers and so on, right? I can analyze documents, I can create a summary, I can do lots of things like that with these tools. The current wave of AI solutions is agentic AI. Now we have these digital agents that are taking actions in IT systems, whether it's a PLM or an ERP or maybe it's your travel website, your shopping website. So these are again agentic AI type of solutions. But we believe, again, this is about a $3 trillion market, and there's going to be value added there as well. But in the future, we believe there's going to be physical agents. Think of robots in a factory. It could be autonomous vehicles. It could be farm equipment, things like that. In every field where physical AI is going to basically bring the promise of AI into the physical space. And that's going to be a $100 trillion market. So that's really the area we're trying to focus on with Omniverse. And if you think about it, right, in the current set of tools in generative AI, there are you can live with some hallucinations. That means essentially it's making mistakes, but since it's providing the guidance to a human user, they can sense what the information is. They can do some corrective action, maybe get another opinion before they use that information. You can't afford to have mistakes when you get into the physical world, especially like autonomous driving and so on. You just cannot afford it.
Embedding it in cars and things.
Exactly. Yeah. So that means you have to do more testing, more simulation before you put those systems into production. That's really why we believe simulation is going to become critical before physical AI solutions become practical.
I couldn't agree more, and I think simulation is becoming one of the key enablers in this technology, right? Because now that we have the computational capabilities, and like you said, how AI has evolved into this realm of can virtually simulate almost anything if you can think it and model it, right? So, but at the same point, I would think maybe we're still in the early days of AI, right? Like you said, hallucinations are still out there. We're still finding our feet under us on some of the real world use cases and scaling this up. So looking 5-10 years out from now, and you think, like the future of AI factories and really, the industrial kind of digitalization of these things. What does that look like in the Omniverse, out from now?
Today we do have a few leading customers, and again, these are public stories like Mercedes-Benz and BMW. They've taken years to put together their simulated environments like a factory. Even TSMC is another great story. They were building our first fab back in the Americas, right? So they had to simulate their entire environment before they can start to fabricate. But these were very expensive efforts and time consuming. So we're trying to reduce the time to value for the next generation of customers. So for that, we really need the tool providers like the PTCs to create these digital environments, or at least the assets in the right formats that can be placed in a digital environment. So that's really the work we're doing with developers and ISVs like PTC, right? So the product companies that they work with, they can create not only the physical product, like maybe whether it's a plane, train, or automobile, but also the digital, twin of that product that can be now used in a simulated environment. So that's the first step, getting the PLM and the CAD systems to embrace this technology. Then we can apply it in a simulated space like a factory.
Right.
And that's how you get to that physical, AI type of solution. So it's a long journey, but we have to start with the product being created in a digital form and being applied in a simulated environment.
And I've seen some of those early kind of use cases and demonstrations and some of the things we're doing with you guys in the space, and it's incredible.
Yeah.
But there's still a lot of room and opportunity to grow it, and more use cases will emerge in time that we haven't even thought of.
Yeah,
right?
and we ourselves are a customer, who wants to use those sorts of tools, and we're creating our own digital twins of our boards and systems and computing pods, so that we can use it in our AI factories, and we believe the same thing is going to happen in every other industry as well.
I couldn't agree more. So let's wrap up and move on to some of the next topics here. And I think you spent a good majority of your time at the PTC headquarters here today, and had the opportunity to take time in our corporate experience center. So talk to us a little bit about what that partnership is right now between PTC and NVIDIA, and what that really means for the two companies moving forward.
Yeah, I think there's a tremendous opportunity for us, not only as a partner where we bring technology to you guys so you can incorporate into your products. And PTC's story is really, quite complete from an end-to-end product life cycle, from all the way from a requirements. You're not starting at a CAD design, you're actually starting at the requirements and systems engineering before it goes to product engineering, manufacturing, and then service to end of life. So I think the NVIDIA technology, whether it's just accelerated computing, accelerating all your applications, or bringing digital technology like Omniverse into the right parts of your application, is going to be one value add that we can bring to you guys. And similarly, we can also be a consumer of that end product that you build. Today, we have to essentially hand build some of these tools ourselves, and we're really looking for PTC to provide us that capability. So that we can have a better starting point, invest our dollars in the right space so that we can add value to our business as well as to our ecosystem.
Yeah, and it's been really exciting to work with NVIDIA. I think back to my days in college when I used to build my own computers and my own gaming machines with GeForce GPUs, and to see where you are today and how PTC is, we're really helping each other on both ends of the spectrum, right? Getting that data that's so important from a design and lifecycle management perspective into the hands of a company like yourself with your tools to then take it to that next level and model an entire building or a factory or an assembly line, right? And we couldn't do it without you guys. So it's really great to be working with NVIDIA and have your partnership.
Yeah, thank you. Yeah, I think again, we are trying to go from a vendor-customer relationship to more of a partner where we're co-developing for the mutual benefit of each other as well as the larger, ecosystem that we both participate in.
Sure. All right, well, Manish, thank you so much for this conversation. This has really been great. I just want to wrap up on some of the topics we covered today. So, digital twins at scale, right? Really simulating, each environment in real time, right? Whether it's a factory floor, to autonomous vehicles, and really helping companies speed up development and reducing their risk, right? We talked about seamless collaboration, right? Integrations to tools like ours with your libraries and tools like Omniverse, and how that's really enabling these scalable workflows for engineering teams and suppliers globally, right? Really providing that visibility that they've never really had before. And then last but certainly not least, the AI-powered product development, right? Much more to come here in the future. We're embedding AI capabilities into our tools. We're working with folks like yourself, and how the Omniverse libraries, they're really central to your vision and ours to continue to move faster, smarter, and really help companies have a more resilient design process, right? So thanks again so much for your time today, Manish. It was really great.
Well, thank you. Good to see you.
Likewise. Additional links can be found in the description below, and don't forget to hit that like and subscribe button to stay wired in. We'll see you next time.